Welcome, everyone. Thank you for joining us. My name is Lloyd, and I'll be your moderator during this session. I'll be monitoring the Q&A and the chat box, so feel free to ask any questions during or after the presentation. The presentation you're about to see is pre-recorded, and Roman will be live after the presentation to answer any questions you have. Okay, I think that's about it. Let's get started.
Hello, everyone. Welcome to this talk about FHIR data and reconciling FHIR data with some incoming streams of data. We'll get into exactly what that means in a moment. So first of all, who am I? My name is Roman Polyanovsky. I'm a software developer at Google Cloud. This is a picture of me before my homemade haircut. After my homemade haircut, I don't really turn my camera on anymore. So what is this talk about? This is intended to be a pretty high-level discussion, mainly of challenges of merging streams of data into a FHIR store, especially at scale. And when I say streams of data, I'm sort of referring to transactional formats like HL7v2, for example, and we'll kind of get into the depths of that in a second. And I'll also talk about some ideas for solutions and architectures that maybe could help with resolving some of the challenges we're going to talk about, and some gaps and pitfalls of those solutions, or things that we still kind of need to keep talking about. So let's kind of hop into our premise. The world in FHIR is sort of a single state, and I'm not talking about like FHIR messaging. This is specifically referring to FHIR resources, and this whole talk is sort of talking about just FHIR resources. And other formats like HL7v2, for example, are not a complete state. They are transactional or event-based, and they represent some sort of continuous stream of updates. And so if we start off with like such an HL7v2 message, and we want to put it into our FHIR store, some of the steps we might take would look like we have our input message here. We would map it to FHIR resources, and there's a little bit of subtle product placement here. We have some technology to help with this mapping step on GitHub. It's all open source, so please have a look. And lastly, after we've mapped our HL7v2 message to some FHIR resources, we reconcile them or merge them into our destination FHIR store to make this complete single state of the world that's like as up to date as our stream of HL7v2. And on the surface, this is pretty simple. However, we start running into challenges when we try to start scaling this up. So concurrency, as in having many concurrent streams, maybe in different formats even, with no real synchronicity between them, start introducing things like race conditions, and you have to make sure that updates are applied in the right order, especially with something like HL7v2's omitted field, where the intention is that you're applying an update on top of whatever data is already in the store, and so that data has to be kind of up to date. Otherwise, your whole updates are going to be offset. So that kind of leads me into out of order updates. You know, if you have a message coming in too early, or more specifically, a bunch of messages coming out too late, what you can end up with if message 1, for example, has this HL7v2 omitted field, then maybe message 1, message 2, and message 3 all will kind of apply on top of this incorrect message 4 value. Even though message 4 was supposed to overwrite that field with something else, or you know, a next message is supposed to do something else. And so you can kind of propagate this error throughout your messages. We also want to maintain an accurate history, so we want to be able to support historical queries on our FHIR data. And so we don't want to pollute the FHIR store with too many things, and hopefully we want to have an accurate history in our destination FHIR store of every resource. We'll see why that's a little tricky specifically. And we want to be able to support arbitrary merge logic. So maybe the way you merge these resources with their existing states, it's not a simple patch or a simple put every time, but really you want to merge different fields in different ways, or you have some kind of very specific bespoke scenarios that you need for your business logic to support. And so you need a place to just implement that kind of logic. So let's talk a little bit about an interesting kind of architecture that helps address some of these challenges, simplify them a bit, but also has its own kind of quirks and things that I'd love to keep talking about. So we start off with our HL7v2 messages, which are really HL7v2 streams. We map them into our FHIR resources like we did before, but now instead of putting them into the FHIR store that's at the end of our project, we kind of just dump them into this staging area. And the staging area is sort of just a record of all the raw mapped resources. There's no reconciliation. We just put all of the resources directly in there. And when I say put, I mean literally like HTTP put. There's no matching by identifiers, nothing like that. We want to, at least not yet, we want to just keep a raw record of everything that was mapped from all of our streams. And all the resources going into this staging area are effectively immutable. So we're never going to change or update those resources. We're just going to add more resources into it. And then we're going to run a reconciliation service or our reconciliation logic from that staging area. And we're going to take resources from the staging area, we're going to merge them, we're going to reconcile them, perform whatever that bespoke arbitrary merge logic is, and we're going to put them into our final FHIR store, kind of overwriting whatever is there and creating a new version. So let's talk specifically how this addresses some of those challenges I brought up. So first of all, concurrency. Immutability helps with the whole concurrency issue. When the FHIR resources are immutable, you just keep dumping things in there. And then the reconciliation service will kind of take care of sorting and just resolving race conditions and things like that, because all the resources will just kind of already be there, and they can be resorted as needed. And that also will touch on out of order messaging as well for that. The problem here is to get the resources that are in this staging area, or rather get all the relevant resources you need for a single reconciliation operation. So if I just got like my ORU message, I want to get my observations, I want to get my patients, encounters, diagnostic reports, all relevant to that message and all the messages that kind of touched on those resources before it. And so that's going to be a little bit tricky with just like simple FHIR search. That being said, the staging area does not have to be a FHIR store. It can be something else, but making it a FHIR store would be a little bit more elegant in a way, because you get to manage those FHIR resources as FHIR resources with FHIR operations, which is also a limitation at the same time. Reverse linking can help with this, with grabbing those resources, maybe some clever labeling, searching by extension, definitely, so you can kind of add labels to those messages, maybe like the patient that it's referring to and the message type, and then you can go back and get all of those by searching by extension if you put those labels in an extension. So that could also help. Let's move on to out of order updates. This is pretty simple. When we pull those resources out of the staging area, we can just resort them based on whatever ordinal we want. The trick is we have to pick an ordinal that represents the real world relevance of that message, or rather that resource. So not the timestamp that the resource was inserted into the staging area, but maybe the timestamp when it was produced, when the original message was produced or something like that. That's not too hard. Maintaining the history is still a bit of a problem, because at the end of the day, the destination FHIR store history is immutable, and we can't really change it. Even if we get an out of order message and we know what the correct history should be, we can't really update that. And so there really is no kind of amazing solution, though we do have a perfect, always correct history on the staging store or the staging area. So if you can run your historical queries against that staging area, then that kind of at least gives you some place where you can run the historical queries. But that still needs a little bit of discussion about what we can do there. And the arbitrary merge logic, like I said, is in that reconciliation service, and you can do whatever you need. You get all the resources you want. Back from the first concurrency slide, I was talking about like fetching those resources from the staging area. You take all the resources you need, perform whatever logic you want to do, and update your final FHIR store. One concern is that the staging area can get too large, and you can kind of remedy that with snapshots, by like sort of snapshotting your reconciled final versions every now and then. So let's quickly run through some conclusions from this talk. I'm running out of time. So reconciling FHIR resources is a little complicated when you try to scale it with concurrent streams. You run into race conditions. If you have to deal with out-of-order messages, when you have to deal with very transactional updates like HL7v2, where each message may depend on messages that came before it. And searching and querying limitations kind of make some of these challenges tricky, even in the intermediate staging area, which still simplifies these problems by introducing immutability. It lets you sort and resort your messages, which kind of helps with the history and out-of-order messages issues. And you still have a complete history of all of your individual events that you can process kind of whenever you want. So lastly, please reach out to me at romanpoly@google.com. I'm really excited to discuss more of this. And thank you very much. I guess we're going to hop into our Q&A.
Super, thanks, Roman. Let's proceed to the Q&A now. Okay, the first question. Is the idea of the staging area to store the message header and bundle, then move to the final repo?
Yeah, so so part of that depends on how you're mapping your initial message. So if you're outputting a message header in a bundle, then that's probably the way you want to store it. However, it's possible that you're going to have trouble reconciling the entire bundle as one unit. You may want to sort of store the resources individually and then put the bundle in, or rather rebundle them sort of at the reconciliation stage. Like I said in the talk, by either searching by some tag or some other labeling, just so you can kind of mix and match resources easier across bundles.
Okay, the next question. Can the staging area be a CDR?
Can you expand that acronym?
Yeah, I think I just got a question here. Can the staging area be a CDR? Yeah. And that's from
Critical Data Repository.
Yeah. Yeah, do you want to let me ask the question again?
I'm not familiar with that.
Can the staging area be
common. I'm not familiar with the specifics of a CDR. However, the staging area can really be any document store that you want. The idea is that you're sort of to the entire process.
Okay, yeah. Next question. How does the staging affect performance? E.g., can you see it? Can you use it in a real-time application?
Roman, I saw that you were speaking. I think you're having some mic issues.
Yeah.
Can you retry again?
You can. This kind of.
You're cutting out at the moment.
Yeah.
Am I audible?
Yeah, now you're a lot better.
I'm having some. Yeah, I seem to be having some connection issues.
Okay. Do you want to answer that question again? How does the staging affect performance? E.g., can you use it in a real-time application, for example?
Okay, so hopefully you guys can hear me now. I think I fixed my connection.
Yes.
Okay. So it does affect performance. However, I think you can still use it in a real-time application. This also kind of, and I left this a little bit vague in the talk intentionally. It also sort of depends on what your intermediate or staging store is and what your sort of like those arrows going from your original message to the staging store and the reconciliation arrow are built upon. So if you're using something like a streaming data pipeline like Apache Beam or Google Dataflow or whatever that kind of thing is, if it's streaming, then it's going to be whatever the latency of that pipeline is, which is usually suitable for real-time applications. You are going to introduce a delay, 100%. However, it should still be sort of reasonable for real-time applications. So I guess we're talking like seconds to minutes rather than hours of introduced latency.
Okay. Yeah, I got another question. What are some good ways to write from staging repo to final?
So this is sort of like a bit of a question mark. I don't want to get in trouble for talking about things we're working on that I may not be allowed to talk about. However, generally those solutions that I kind of talked about before, so Apache Beam or like any real-time pipeline are a good place to start. Yeah, I think that's essentially your best bet is to have whatever your favorite data pipeline solution is, just kind of running, triggered by every incoming message into the staging area. Once you write that message into the staging area, you trigger a sort of second pipeline. That's the reconciliation arrow, and then you execute your reconciliation logic there. And I think someone also asked, what is in the chat, like not in the Q&A, what does reconciliation mean exactly? And this just means merging those resources, those like partial message derived resources into that destination FHIR store where you have like the latest state of the world. So it's kind of trying to go from this transactional sort of perspective into a stateful perspective, while kind of keeping things in order and keeping everything like handling out of order updates that may come in too late or too early or whatever. So that's what I'm talking about when I refer to reconciliation. Hopefully that's clear enough.
Yeah, all right. We got one more question. Will this concept be closer to real-time communication and performance unfriendly? I suppose using a database plus sequencing and resequencing logic coupled with a temp database as a temp holding staging does the trick. Please suggest if I'm going down a rabbit hole.
Yeah, it's obviously not the most streamlined solution, and I think someone else asked a question about performance, but there is a certain requirement where if you want to be able to handle like out of order messages and concurrency gracefully, you're going to start running into either having to have a retry loop somewhere where you're like using like an e-tag on your Firestore and you're like hitting it with requests over and over again until you finally like you read from the Firestore, you hope no one modifies that resource in the meantime, like perform your merge, your reconciliation, try to put it back, it fails, oh no, you could like retry this again. You could end up with like starvation and like a whole bunch of other concurrency issues, or this sort of at the small cost of performance you run into, or rather a small cost of storage and possibly some latency, you run into alleviation of kind of all of these concurrency issues just from having an immutable sort of message store with like events that you can then sort of rehydrate in your reconciliation. This is very similar to like event-based data storage patterns that are kind of common in sort of large distributed stores already. And hopefully this is just trying to alleviate some of that concurrency issues that you'll run into. The idea is you're going to run into worse performance trade-offs and more complexity than this if you try to do it with like a retry loop. So I hope that answers your question.
Yeah, Ronan, thanks for taking the time to answer all your questions. We've seemed to run out of time. Yeah, we hope you all the delegates found this session useful. Please do not forget to rate the presentation and use the Q&A function if you still have questions remaining. Thank you for attending, and we'll see you next time. Goodbye for now.
Thanks, everyone.